The electricity in your home travels near the speed of light, yet the electrons inside the wire barely move. What actually reaches your devices is far stranger than you think. The common myth: most people believe electricity moves like water flowing through a pipe. They imagine that when a power plant turns on, electrons immediately start racing through wires, traveling hundreds of kilometers from the generator straight into homes. In this picture, electric current looks like a fast-moving river of tiny charged particles. This idea feels correct because we see wires and we see devices turn on. So the brain assumes something physical must be traveling fast inside the wire. But this mental image is wrong. The myth comes from DC current diagrams and oversimplified school explanations. Textbooks often draw arrows showing electrons moving in one direction. This creates the illusion that electricity behaves like flowing water. In reality, those arrows do not represent speed. They represent direction of force. Another reason the myth survives is because light turns on instantly. When you flip a switch, the bulb glows almost at once. So people assume electrons must be traveling nearly at the speed of light. But if electrons actually moved that fast, wires would heat up violently, and power systems would fail. Here is the hidden truth. Electrons already exist inside the wire, long before you turn the switch on. They are not waiting at the power station to begin a long journey. When the switch closes, an electric field forms instantly along the entire circuit. That field pushes nearby electrons everywhere at once. Each electron moves only a tiny distance, bumping into atoms, passing energy forward like a chain reaction. This is why the water pipe analogy fails. Water flows from one end to the other. Electrons do not. In AC power, electrons simply vibrate back and forth around fixed positions. No electron travels from the power plant to your phone charger. The myth feels natural. It feels intuitive. But nature does not care about intuition. Electricity is not fast-moving matter. It is fast-moving information and energy, carried by electromagnetic fields. And once you understand this, electricity becomes far more fascinating and far more strange. So what actually moves? When you turn on a switch, electrons do not rush through the wire. So what actually moves? The answer is the electric field. The moment a circuit is completed, an electromagnetic disturbance is created. This disturbance spreads through the wire and the space around it at nearly the speed of light. This field tells electrons how to move. Think of it this way. Electrons already exist everywhere inside the conductor. They are loosely bound and ready to respond. When the electric field arrives, each electron feels the force immediately and shifts slightly from its position. No long distance travel is needed. In AC power, this field does not move in one direction. It oscillates. The field reverses direction 50 or 60 times every second. Electrons simply vibrate back and forth in place. Energy flows forward, but matter does not. What carries the energy is the electromagnetic wave surrounding the wire, not the electrons inside it. The wire acts like a guide, directing the wave toward the device. This is why signals, power, and information move so fast. The true motion in electricity is invisible. It is the motion of fields, not particles. And that invisible motion is what powers the modern world. Electron drift speed. Electrons do move in a wire, but their movement is extremely slow. This movement is called electron drift speed. Drift speed is the average velocity at which electrons shift when an electric field is applied. In a typical household copper wire, the drift speed of electrons is often less than 1 mm per second. That is slower than a crawling insect. Yet your light turns on instantly. Why? Because electrons do not need to travel far. They are already present throughout the entire wire. When the electric field appears, each electron nudges the next one, passing energy forward. Like a chain reaction, electrons constantly collide with metal atoms inside the wire. These collisions slow them down and create heat. This is why current causes wires to warm up, even though electrons move slowly. In AC power systems, electrons do not drift forward at all. They oscillate back and forth around fixed positions. Their average forward motion is essentially zero. So the paradox remains. Electrons move slowly. Energy moves fast. This difference is the key to understanding electricity. It is not speed of particles that powers your world, but the speed of fields. Why AC power is special. AC stands for alternating current. Unlike DC power, AC does not push electrons in one direction. Instead, the electric field reverses direction. Again and again, 50 times per second in some countries, 60 times per second in others. Because of this reversal, electrons never travel long distances. They simply vibrate back and forth around fixed positions in the wire. This makes AC power incredibly efficient. For long-distance transmission, AC voltage can be increased or decreased easily. Using transformers, high voltage reduces energy loss, allowing power to travel hundreds of kilometers with minimal waste. This is why entire nations run on AC power. Not because electrons move far, but because energy moves smartly. A simple analogy. Imagine a long line of people standing shoulder to shoulder. Each person holds a ball. When the first person pushes, the force travels instantly to the last person. Even though no one runs down the line, each person only moves their arms slightly. Electricity works the same way. Electrons are like the people. The push is the electric field. The ball reaching the end is the energy delivered to your device. Nothing travels far, yet the effect is immediate. Why this matters? Understanding this changes how we see the modern world. Power grids, internet cables, and communication systems do not rely on fast-moving particles. They rely on fast-moving fields. This knowledge allows engineers to design safer wires, faster networks, and more efficient energy systems. It also explains why electricity reacts instantly, why signals travel so quickly, and why physics often feels counterintuitive. Electricity is not about motion you can see. It is about invisible forces shaping everything around you. And once you understand that, technology stops feeling like magic and starts feeling like physics.